Thank you for being here. Welcome. My name is Keith Humphreys. I chair the advisory group for the Stanford Health Policy Forum, which is a program of the Department of Health Policy, chaired by Dr. Doug Owens, who's right there today. This forum really, I'll be honest, it started with a sense of panic by an article that both Doug and I read. So let me ask you, by show of hands, is any of you heard of mirror life? Yes, lots of people have. Well, I hadn't until I read this thing, and that, apparently the structure of the molecules that create life, DNA, RNA, proteins, have a chiral structure, which often thought of as being right-handed or left-handed. And there was an editorial in Science, first authored by Dr. Adamala and colleagues, which said, we're increasingly getting the ability to manipulate molecules so that we could flip a right-handed molecule over to a left-handed structure, a mirror of something that doesn't, so it would no longer have a parallel in nature. And they were asking, what would happen, say, if you did that with a dangerous bacteria and it was released either through malice or through accident into the environment? Maybe no immune system of any living creature could recognize it. So the stakes of this are really high. And when I read that, I also thought of something one of our guests, David Relman, had shown, a different kinds of potential threat in a talk he gave at CSAC some years ago, of just an ad from a terrorist group saying, we are recruiting physicians and chemists to try to engineer a new hepatitis strain that is deadlier and harder to treat than the ones we have. Come join us. And it best reflects reality that it is getting easier and easier to do these things. And certainly there are things we can do with molecular manipulation that are amazing and good, but also there's substantial risks to public health from these. And that's what we wanted to talk about today. As we get into this, I want to say this is a topic of potentially some controversy, so I just want to state what Stanford's policy is. Controversy is great, free speech is great, and at the same time, we ask you to hold questions until the question and answer session, and please not to be disruptive anyway, because then we would have to ask you to leave, and we don't want to do that. So let me introduce our distinguished panel today. Starting on your left is Hank Greely. Hank is the Dean and Kate Edelman Johnson Professor of Law and also a Professor of Courtesy, by courtesy of Genetics. And he's the Director of the Center for Law and the Biosciences at Stanford University. He specializes in ethical, legal, and social issues arising from the biosciences, particularly genetics, neuroscience, stem cell research, and assisted reproduction. He's the founder and a past president of the International Neuroethics Society and chairs the California Advisory Committee on Human Stem Cell Research. Then in the middle is Dr. David Relman. David is the Thomas C. and Joan M. Merrigan Professor in Medicine and a Professor of Microbiology and Immunology at Stanford University. He's also the Chief of Infectious Disease at the VA in Palo Alto. He was a pioneer in the identification of previously unrecognized microbial pathogens and in the modern study of the human microbiome. Relevant to today's topic, he was a founding member of the National Science Advisory Board for Biosecurity, chair of the Forum on Microbial Threats at the National Academies. And from May 2024 to January 2025, he was senior advisor for the Office of Pandemic Preparedness and Response at the White House. And our interviewer today, as ever, is our longtime friend and host, Paul Costello. Paul ran communications at the medical school for, almost 20 years, and has thankfully continued to be part of the forum. He's now an adjunct lecturer in the Department of Medicine and a global health faculty fellow in the Stanford Center for Innovation in Global Health. Very happy to have you all here, and please take it away, Paul.
Thank you, Keith, and thank you, everyone, for joining us today. Keith mentioned the article in Science, and he used the word panicked. And I'm wondering to my panel, is that the right word? Is David, when you set about writing the piece with 30 of your colleagues, what was the intention? What did you hope you would get out of the column? And was it basically firing a warning shot?
There were a number of purposes, I think, as we thought about whether, in fact, even to write a piece about something that we had talked about for a couple of years prior. But one of the decisions was that we had realized that we were unable to disprove the possibility that what we had been talking about was something that could plausibly threaten a great deal of life on this planet. And as much as we hope that there might be a fatal flaw in our logic, we could not find one. So purpose number one was to raise this issue with a much broader audience with the hope that we would receive more informed input and learn that there were other considerations we had not thought about. A second was to make clear that the scientists that had been the very ones to propose this construction, the creation of this mirrored form of life, were the same scientists who are now saying this is something that we ought not to do, and that this group of scientists would be declaring that their own purpose had been misconceived. And again, now it would be the scientists who were calling for a moratorium on the very work that they had once been so enthusiastic about. It, to us, would also seem to be a message to the public that scientists were willing to take ownership of their ideas and the implication of their ideas, and even to declare that what they had thought was a good idea was in fact probably a very bad idea, and willing to own it.
You know, you mentioned when we spoke last week that at the Pasteur Institute conference last summer that you were hoping that some skeptics would show up. You were hoping that someone would put holes, but no one did. What was that like what was it like to have a uniform decision making that this was dangerous and that this should be halted, that there should be a moratorium?
Yeah, for me, quite humbling and sobering. And it was not new to me this past summer in Paris, because the whole MO for the assembly of our group was to seek in a staged fashion additional kinds of expertise that we thought might better inform our breadth of understanding. And so we picked experts from around the world who were directly involved in this work or knowledgeable about it, but from different disciplinary angles, hoping that each one, as we added them on, when told of our logic and assessment, would say, no, you've missed something. Here's where your assumption is wrong, or here's where you've just failed to understand something properly. That did not happen over the course of 2 years. This began really 3 years ago or more. And I think for me, it was 2 years of gradually coming to grips with the possibility that now, for the first time, for me, there was something that I truly believed could conceivably threaten much of life on the planet. And I with a side career of thinking about how things can go wrong, had not come across something that I could truly, assert had that possibility.
Hank, when you and I spoke last week, I said I talked to a researcher who read the science piece and he was especially panicked. And you said that is not something we should, get into, is panic. What is and I sort of felt that you had some skepticism when we spoke.
I'm not an expert on mirror life. I'm not an expert on biology. My last bio class was in 10th grade, and I hate to think how long ago that was. We knew how to spell DNA, but that was about it. It's not that I think there's not a huge potential risk. I think there is a big potential risk. And it's not that I think a moratorium is a bad idea. I think a moratorium is a good idea. But I've been working in bioscience issues for about 35 years. And one thing I've learned is it's almost always more complicated than we think it's going to be. Things are never as easy or as clear, and they don't work out as directly. Life is extraordinarily complex. So I am not convinced, and I don't think David is convinced, that this would be the end of life on all Earth, but I am convinced that there is a significant enough risk that we should do something about it. How big the risk is and what we should do about it are the, to me, interesting questions. And coming at this from a law and policy perspective, it's really, my angle on this is how, if we decide we should do something about it, what should we do and how can we do it in a world that doesn't give you good control mechanisms over things like this? So to me, it's that side of it that is maybe even harder than the biology. Actually, is harder than the biology. I will say, though, I don't think we should panic, in part because it's several years away, and in part because panic seems to me the world's least useful emotion. Right? Pain is useful, fear is useful, they warn you. Panic, when you panic, you kind of lose your sense. You get discombobulated. We don't need to panic. We do need to be worried. We do need to take clear, thoughtful steps, which I think David and his group have been doing. But panic is a bad word. Panic is a bad thing.
David, Hank, you came out of, in the 70s, the Asilomar Conference. Is that sort of a model on how to get a global sort of consensus on mirror life?
So that's a great question. I was actually just at Asilomar earlier this month. I co-hosted a meeting with Sergiu Pașca on yet another amazing biological feat, human neural organoids. And it's 50 years since the famous recombinant DNA Asilomar conference, which Paul Berg, David Baltimore, Maxine Singer, and others led. That was an important milestone, I think, in the history of science, in the history of science and society. Like everything in history, it is subject to revisionism and revisions on the revisionism, and every new generation of grad students needs to take a poke at what the previous generation has said, or else they don't have anything to write about in their dissertations. So there are people who downplay the importance of Asilomar. I'm not one of them. I think it was really important for the scientists involved to say, you know, we are worried about this. We think we should declare a moratorium. We think the world needs to pay attention to this. It was important both for recombinant DNA, although the risks they feared did not happen. Part of that was because they maybe weren't as risky as they thought, but part of it was because of the things they set in motion. But it's also important to remember Asilomar, which was an effort for science to take control and kind of to prevent government intervention, because Congress and the mayor of Cambridge, Massachusetts, and a bunch of people were screaming for clampdowns. Asilomar turned into NIH regulations, which created biosafety committees. And so where Asilomar actually got teeth, at least in the United States, was through the impetus it gave to the development of NIH regulations, which then became broadly adopted around the world. So the revisionists do have a point to some extent. It wasn't a straightforward scientists take control and stop things and are wonderful heroes, although I think the scientists did a very good thing there. But the implementation of it was more complicated and more difficult, as is always the case.
David, I have a question about the science piece. It talked about $500 million investment, that what it would take to bring Mirror Life to fruition. And it also talked about the technical advances that we would need, that would need to be undertaken to actually bring this to fruition. What are those? And $500 million doesn't sound like a lot of money. And it is a lot of money, but it doesn't sound like a lot of money. Why was that a significant part of the paper?
Well, I mean, I think that's a good question. And I think in retrospect, we might not have wanted, certainly did not intend for too much attention to be drawn to that number. Certainly sitting here in Silicon Valley, those sorts of numbers mean less than they might to a person on the street in Omaha. We were just talking about Omaha. Well, actually, Omaha is the home of Warren Buffett.
Yeah,
sorry.
Person on the street
Okay.
other than Warren Buffett.
It was meant to give a sense of the scale and scope of effort in scientist funding terms, but funding of science now is so much more expansive and almost disruptive kind of landscape. I think I would downplay that number. Clearly, we know that sums of money like that can be had much more easily than one might have thought 10 years ago. But I think the bigger point was that no one individual today could go about creating a fully self-replicating, certainly not a robust form of mirror life on their own or even with their friends, simply because of the technical hurdles that still remain that will only be solved by large groups of people with broad expertise and banging their heads for days and weeks and months and probably years, even with the enabling power of AI. And that was the point. And that point also then emphasizes the opportunity we have now, which is that we're now in a window of time when we don't have to worry that having disclosed this risk to the broader world will now inspire a small group somewhere to go and make it by next week. That's not happening with no matter how much money one has. And instead, we have this period of time to think much more clearly about, to Hank's point, what are the most effective ways of mobilizing worldwide opinion. I mean, and this would be one of my little mini retrospective bashes about Asilomar, which is, even though it was an embracing of the world of recombinant DNA biologists, it did not embrace much of the rest of civil society, nor was that its purpose. But today, you'd have to think clearly about who are the other constituencies that need a voice in a conversation like this about what do we do? Well, we have a little bit of time to try to figure out how to do that. And we have a little bit of time to figure out the various mechanisms available and how to deploy probably a bunch of them.
You mentioned AI, and I'm curious if the acceleration and growth of AI, we're at the nascent period of AI, if that will charge up and release and enable this mirror life to come about quicker.
Oh, I think you'd have to conclude the answer is yes. The only question is how exactly and, how much more quickly and through what means. But no, I think you'd have to agree that everything from biological design tools to all kinds of genome language models, pioneered here at Stanford, in fact, will all have a facilitating effect on this. And the very scientists who were doing this work, the would-be folks, as well as those that continue to work on the natural chirality synthetic life quest, they all are looking at AI as an important enabling factor.
You talked about, and you had a conversation recently with people at the UN, and UNESCO is involved in giving some guidance on this or taking into deliberation their large bureaucracies. And I'm wondering what governance model could they actually implement? An institution like the United Nations. Is it the National Security Council? What level of involvement do you hope that they have, and do you think that they have at this point?
Well, I mean, much could be said about this, and there are some experts here in the room besides Hank. For me, the answer is we're going to need all of the above. I would never think that or argue that one approach will be sufficient or even a couple. And so I would be thinking about both top-down and bottom-up kinds of governance models. And I'd be thinking about everything from soft law to hard law, meaning establishment and reinforcing of norms by scientists, for scientists, by civilian sector, for much of the rest of society, all the way up to guidelines and regulation and national law with serious penalties for violation, to international mechanisms, which admittedly have much less of a possibility of true enforcement other than, again, the kind of norm setting and attention raising that they can offer.
Hank, where do you come down on the whole governance issue and organizations like the UN and other organizations to have rules, to have regulations, and to have the power of using their voice?
So I don't think this is likely to be resolved by anyone who has the power to actually enforce a strong position on this. But I think what you do is, as David said, build a whole panoply of different influences and influencers, everything from articles in Science to debates that get a zillion views on YouTube, to statements of guidelines coming out of a National Academy's consensus report, to resolutions from UNESCO, et cetera. I think the hard law side of it is going to be less likely, certainly at the international level. There is no real hard law at the international level other than the law that the countries with power will typically do what the countries with power want to do. I'm wearing a Ukraine flag as some note of that. But international law requires treaties. Treaties take forever, if they happen at all. And one way that treaties happen while taking forever is they have loopholes and ambiguities that allow different countries to sign on to them, and they don't really have enforcement mechanisms. So I think a hard law solution at the international level is unlikely. A hard law solution at national levels is possible, but likely limited to particular nations, or maybe some regional groupings. Maybe the EU could do something like, something broad with respect to this. And there you also have to worry about this at the international level also, but less so because it's less powerful. At the national level, you have to be careful what you wish for. One of the things with Asilomar was a worry that if Congress started getting involved in it, God only knew what Congress would do. And I would say since 1975, that question has become even more uncertain and charged here in 2025, whatever year it is, if Congress were to do anything. We've got some nice examples of situations where Congress tries to do one thing and ends up banning other things inadvertently, or where a regulatory body says it has banned something. When Dolly the sheep's birth was announced, there was a hysteria that some of you will remember. We went from one sheep to armies of cloned warrior slaves overnight. And countries and states, including California, around the world, passed laws banning human cloning. And the Brits said, in a very smug way, oh, not to worry, we've already banned human cloning. And in regulations they had adopted 7 years before, there was a section that said ban on human cloning, which then described a process that they were banning, which was not the process that was used to make Dolly. So governmental action has its downsides, but it can be useful. Everything requires care and attention. I think it's mainly useful in terms of building a consensus and building the sense that this is a bad thing and people shouldn't do it. Even if it isn't enforceable, the more that happens, the less likely people are to do it. They're certainly not going to it's less likely they're going to get grants to do it, less likely they'll get postdocs and grad students who want to do it, deans who want to do it. Now, you always have the possibility of the Silicon Valley billionaire going to an island off the coast of Honduras and doing whatever the hell he wants, almost certainly he wants.
Or a nation like North Korea.
Right, but those things I think help. And there's a wonderful example of that. Regulation of human embryonic stem cell research pretty much came out of a 2005 report by the National Academy of Sciences Committee that has no legal force except in a few jurisdictions, but is followed almost everywhere around the world. It was an expert report. It made sense. The scientists were willing to live with it. The concerned and informed part of the population, which was small but non-trivial, was willing to live with it. And 20 years later, it still has, by and large, held the line. Bans on human cloning. There are legal bans, but not in every country. And yet, no one has, as far as we know, tried to clone a human baby, since the early aughts and shortly after Dolly's birth. He Jiankui and the CRISPR twins, who are now, by the way, 7 years old, we think. We don't even know whether they're alive. China's releasing no information at all about their health. He was the exception. He violated a consensus, but since then, nobody has tested it again. So I think these things do have power, but they come from not one source, but they come from a building of sources ranging from statements by advisory groups, statements by UNESCO, statements by others, to laws that have some effect somewhere in some ways. They're all useful, but they're complicated.
In Paris, one of the things that was proposed, I think it was proposed, to create mirror life in the laboratory to study the risks. And David, you were very negative about that. You called it experimental gamble. Can you talk more about that?
Yeah, I don't.
Was that not Paris? That was certainly in the
Yeah,
in the
I don't
science
think
piece.
that anybody has proposed making it to study it at this point. I mean, this is what makes this particular issue somewhat distinct, which is that we are so far from being able to do it that these other examples in some ways don't serve as perfect case studies, because in every other case, the thing that we feared was either already here or someone subsequently did it soon thereafter, and we could survive the outcome.
For instance, what are you referring to?
Well, the CRISPR babies, or the actual creation of the mammalian transmissible H5N1 virulent virus. The thing that we feared was actually made and then announced to the world as a fait accompli. Now what are you going to do with it kind of response. Here, I think it's possible that were we to allow ourselves to walk right up to that line again, as we already did before knowing it, and then stumble over or be on the verge of stumbling over that line, we're talking about an outcome I don't think we can control. Because, again, the paper and all of our statements are full of, caveats, uncertainties about our conclusions. But if we are right, in the worst case, such an organism is the ultimate invasive species. It has the ability to grow on this planet because all bacteria that we know of can live off of achiral nutrients. So if you made a mirror E. coli, it would grow quite well on things like glycerol or short-chain fatty acids, which are achiral. It might grow a little more slowly than its natural counterpart, but it could grow. But the reason it would keep on growing, unlike its natural counterparts, is because all of the natural mechanisms for population control, for killing, for predation, will not work, we think, and there's experimental evidence to support this. A mirror life form would not be susceptible to viral predation or phagocytosis or killing by any of those related mechanisms. So if we walk up to this line and allow someone to make it and then say, oh, okay, that was probably a mistake, it may be too late. This thing will unavoidably escape a laboratory, and once it establishes itself in the environment, I don't think we would know where it would be, and can't think of an intervention that could be applied broadly throughout the ecosphere to stop it. We're not talking about a human infection or an agent that's dependent on or specific to one kind of host or environmental system. This is something that will grow throughout.
Are you fearful that, what does your gut say about the future in this regard? Are you completely fearful of the potential, or do you put it away and say we need to be cognizant of mirror life and the potential of what it could do? Or do you really think that we're on the verge in 3, 10, 15 years, a time frame, of having to deal with the world where mirror life is a reality? I get a sense that...
Yeah, no, I'm very much of Hank's mindset on the idea of trying to be deliberate, focused, and aware of what we need to do and the time in which we have to do it. I would rather not have to think about 20 years or 50 years from now, because we have a lot of things that need to happen now, and that's what I'm determined to see done through whatever means we have available. If we can even just slow this down, to buy ourselves more time to think this through and arrive at the right, perhaps more nuanced path of risk management, great. But we can't make this in order to understand it better. We have to find other ways of addressing uncertainty and moving forward with what we know, based on the best available information we have at the time.
Hank, what's your feeling about that?
So there are a lot of things I worry about more than mirror life. Everything from a terrorist group using CRISPR to create a nasty pathogen, something that David has worried about as well in the past, to what's going to come next out of Washington, D.C., to what happens when crypto crashes sometime soon, I think. There are lots of scary things out there. To me, this is a scary thing, and it deserves attention, and I think a moratorium is an appropriate step at this point. This isn't what keeps me awake at night, but it's not something that I've studied as a biologist, which I'm not, so I can understand that maybe it's a bit more of a contributor to David's sleepless nights than it would be to mine. But I do think it's something that does deserve attention. It is important, though, to remember that there's nothing we completely control. We're never able to completely predict what's going to happen with anything. At the Asilomar meeting 50 years ago, it might have been that one of those recombinant E. coli that they had created would actually have killed off maybe only half of life on the planet. Maybe not. There was Oppenheimer near the first atomic test was suddenly worried that maybe somebody said it'll set the atmosphere on fire. Well, he concluded it probably wouldn't, and happily he was right, but the risk wasn't zero. You've never got a zero risk. And I think the other side of this, which we haven't talked about so far, risks always have to be considered next to potential benefits. Potential benefits both in terms of whether it's worth doing, so is it worthwhile to do this or not, but also what are the incentives going to be for somebody to try to do it? And if the incentive is, I'm going to make $17 trillion with a product I can predict using mirror life, I'm more worried about this happening than if the incentive is, this will be really cool science and I will be remembered forever, as long as life exists to remember me. So I don't know that I've asked David this question before, but I'm not sure what the driver would be in mirror life, and that makes me also a little less concerned than I might otherwise be.
What would the driver be, David? What would the incentives be?
Yeah, well, I mean, as Hank has said, everything is a bit more complicated than you'd like to think. Here, I think we readily recognize that one of the original drivers towards thinking about mirror life was the known beneficial properties, potential beneficial properties of mirror biomolecules. Mirror proteins are very resistant to degradation. The natural proteases that would normally break down natural proteins don't work against mirror proteins. That means that if you're interested in a protein-based drug with a long half-life, this is a great option. And there is a small pharmaceutical effort underway to exploit the resistant properties of mirror proteins. Likewise, mirror nucleic acids, same thing. Very resistant to breakdown. Also, not very immunogenic. They don't stimulate an immune response, and that's known experimentally. Well, that's a good thing if you're thinking about a drug that you'd rather not have elicit a harmful immune response. So there is that small little niche market. But again, to Hank's point, trade-offs, benefits, and risks, this is an unusual situation where the balance is grossly unequal, because the potential benefits that we can list would fit easily on one hand, and it would be a very small hand.
What are those potential benefits?
So the potential therapeutic value of these mirror proteins and nucleic acids, the use of a mirror cell as a production platform for those potentially useful therapeutic proteins and nucleic acids, and whatever we might learn about why it is that life as we know it on this planet did not proceed down this mirrored pathway in evolutionary time. It seems it never got started. And people wonder. Louis Pasteur wondered in the 1840s. Why was it? And what would have happened? What would life look like? Would it evolve exactly according to the same rules and principles? Well, we think so, but we don't know. So it's these sort of pretty fundamental questions about life and this niche therapeutic market that are the large drivers here.
I would think that one of the things that you really need to think about and think through is, what is the line? What is the line where you stop? And what is the line where, that you don't negate other science?
Right. And that's a big concern. And so we, this community of concerned scientists that have been talking about this now for a while, are at a stage where we're asking ourselves and talking extensively about, if we were to draw a line, how do we draw a line, or lines, plural, that would minimize the harm to the rest of science and yet reduce the likelihood of walking towards the final creation? And for us, the main nuance is, how do we preserve efforts to build synthetic life of a natural chiral sort and yet not build the mirrored version? So there's one place that we've been talking about recently, which is to draw a line just shy of the construction of a mirror ribosome, because of all of the components of a mirrored life form, the one that has unusual challenges for scientists, and the one part that has such a fundamental role in helping to spin up a self-propagating protein synthesis system, is the ribosome. So we're thinking about a line that would say, one shall not construct a fully competent mirror ribosome, and yet building a natural chiral ribosome, although not yet realized, would be allowed. Is that going to work? Not perfectly, no. For sure, no. But that would be one place where we would draw a line, and I think we'd need others, and you'd need other kinds of mechanisms to draw those lines.
And when you draw those lines, who monitors it? I mean, what's the governance?
Yeah.
So where do you go to say, no, you can't do that? You have to stop.
Lines are fraught. I now know from reading Foreign Affairs, where you can read about all of the blunders that our former President Barack Obama made when he said there was a red line around the use of chemical weapons in Syria. And then, to wake up one day and receive unassailable intelligence that it had been done. And then to realize that he had not been clear about what that meant and what the consequences would be, and under whose authorities he made this proclamation. And so lines,
And he was president of the United
and he was
States.
president of the United States, but not president of the world,
Yeah.
unlike others who would like to be such. So lines carry, great risks, paradoxical risks, in their ill use, such that they create perverse incentives or self-destruct when they've been drawn in an imprecise or thoughtless way, and they're easily violated and shown to be null and void. So you've got to do it with clarity of purpose, clarity of definition, proper authorities, clarity about consequence, and buy-in from those for whom you intend these to serve.
What have you anyone been in touch with this administration, the Trump administration, about, are they engaged in this? I know that the Biden administration was engaged, very much so. They had lines in every department that would be affected by Mirror Life. What's the current, how do I put it gently? What's the current interaction or participation in the notion of what this is and how to curtail it? Is anyone in the Trump administration paying attention to it?
Yeah, it's actually hard for me to answer, not because I know all these things and won't say, it's because I really don't know, nor perhaps could anyone really know in this particular set of circumstances. What I can say is that in the previous administration, there was an immediate embrace of the idea that this should be led by scientists. They loved the idea that scientists would be the voice for, the call for action, and that there were technical reasons for undertaking these actions, and buy-in from the community that would be affected. They loved that and wanted to play sort of a backseat role. They were going to respond to suggestions and recommendations that came out of the scientific community and other communities. But they ran out of time. And all I can say about this administration is that they've been very clear about so-called gain-of-function research. They've drawn a much harder line about that, a fuzzier line about what it is, but much more determined to see that it be properly regulated, whatever that might mean. Now, I don't know that they have made declarations about Mirror Life and whether it falls within some sense or rubric of gain of function, but the Congressional Research Service issued a small report about Mirror Life and said, this is of concern, we need to take this seriously, we, the Congress, should look at this carefully, to be determined. And there have been sort of rumblings elsewhere in the government, but frankly, I think maybe like Hank, they have other things that concern them on a day-to-day basis right now.
Mm-hmm.
Building a ballroom.
Building a ballroom. Do you ever see Don't Look Up?
Yeah. Yeah.
So I do think that there is going to have to be something somewhere that offers opinions or makes decisions about what research should and shouldn't be done. Research on non-mirror synthetic life, research on mirror biomolecules for pharmaceutical or other purposes. And when does it get too close to what you're worried about? The ribosome idea might be where they end up, or it might be others, and but there will need to be something that answers those questions. It would be nice if it were something that had international clout, not necessarily legal authority, but international, was respected by scientists internationally. It's unlikely to be anything that has real legal authority.
Where would that come from?
Well, that's a really interesting question because it needs to have some sort of legitimacy. In some eras, it could have been a United Nations thing. In some eras, it could have been a WHO thing. One of the things that's happened with human embryo editing, human embryo genome editing of human embryos, has been a series of opinions and guidances from the WHO, but also from a commission that included the U.S. National Academy of Sciences, the Royal Society of the UK, a variety of other national societies. They have come out with recommendations that in some areas could be good enough. A problem is, at least in the United States, and I think in many other countries, this may not be one of those eras. We are in the era of chemtrails. We are in the era of Bill Gates microchips and vaccines. We are in the era when any conspiracy theory seems to be enthusiastically adopted by at least a third of the country. And, you know, David, I hope you're not getting death threats yet, but somebody is likely to decide that what you're doing is somehow an evil thing and you need to get death threats because of it, because that's the time we are living in. We can't just give in to it, and I think things like the international bodies with some clout, with some respect, need to get involved. But they also need to do something that we haven't done very well, and that is engage with the public. Public engagement is one of those things like apple pie, that unless you're on a diet, everybody likes it. That's the question.
On something like this.
How do you engage the public? And there are a variety of answers, from finding out what they really believe. There's a great sociologist at UC San Diego named John Evans, who's now written 6 or 7 books looking at various bioethics issues and seeing what real people believe compared to what we think they worry about. So this Human Neural Organoids conference I was just at, he spoke at. And the ethicists and the scientists, they think people are worried about the organoid having consciousness or the organoid feeling pain. An organoid is a basic, kind of the size of a black peppercorn, of human neurons, 1 million or 2 million neurons that self-organize in ways that are really fascinating and potentially helpful. Do they feel pain? That's one of the things we worry about. Turns out that the general population realizes these cells came from some person, and maybe if they came from Paul Costello, maybe they're Paul Costello in some sense. Maybe some of your identity actually carries over into the organoid. No, none of the scientists think that, but the public thinks that. And it's useful to know. A substantial chunk, like 40% of the public he quizzed about this, worried about that. That was their biggest fear about organoids. It's useful to know that. It's useful to get them involved in projects and in committees and so on, but that's not easy. It's not easy to find people, and once you've got people in, it's, sort of, again, be careful what you wish for. Maybe the public that you get engaged in this ends up making recommendations or blocking good recommendations and pushing bad recommendations. But legitimacy is, I think, increasingly hard to get, and in this atmosphere is increasingly important. It's not just here. Throughout science, there are issues like this where science needs to figure out ways to get the public engaged in a way that is willing to participate and see the costs and benefits. And that does not mean giving them lectures and explaining to them what the science really says. That usually doesn't work. It means explaining things, talking to things, yes, but it also means listening to their concerns and showing that you're interested in their concerns, even if their concerns aren't necessarily as high on your priority list as your concerns would be. And that's going to be hard.
Yeah, I would just add, exceedingly hard, but exceedingly important. And I worry that my colleagues, are not willing, in some cases, or not able to put even a half a day, a year into an effort like that, of engaging in public fora, in speaking with people, hearing their issues. My informal poll, Hank, with rideshare drivers, after explaining the pros and cons of mirror life, has led to a uniform response, which is, what the hell are scientists thinking? Just saying.
Yeah.
What the hell are scientists thinking?
But if you'd explain like synthetic non-mirror life, it probably would have been the same.
It's also the same.
Thank you. We're now going to take questions from the audience. Thank you both for. In the back there, 1, 2, back there.
Yeah, thank you so much. I am a Stanford alumni, a member of the community. So my question is for Hank. On this issue of the credibility of scientists and institutions, what's your opinion on the play that I heard people like Anthony Fauci created this problem during the pandemic, meaning that during the pandemic we had all this advice from experts, don't do this, don't do that, wear masks, don't wear masks. Vaccines work, don't work when they don't protect against. I mean, they're good at minimizing death for certain demographics, but they don't protect against contagion or these things. And how that damage, in my opinion, is going to affect the topic of the discussion, and also in the years to come. Thank you.
So, science is hard. Policies are hard. Making policies at a time of crisis is always hard. You will never be entirely right about anything. I think for the most part, the scientific establishment did a pretty good job, except maybe, and I understand why, maybe underselling, understressing the uncertainty. But if you really think it's important for everybody to wear masks, then saying, but of course we're not sure about that, undercuts that. It goes to this sort of deep tension between real-life policy and academia. We want to be as careful and correct and precise as we can, but if you're trying to get people to do something, you can't drop all the footnotes. You can't put in all the caveats, or they're less likely to do it. I think certainly because of the quirks of what was going on in the political system, this has become a bigger deal than it would have otherwise, but it still would have been a big deal. Scientists say do X, but later scientists say it's not airborne. Although what they meant by that wasn't entirely clear, it turns out it is airborne. That hurts. And what you have to do is say, well, we were wrong, but we weren't unreasonable, but don't try to defend yourself too much. And say, here's what we think this time, here's why we think it, and, come on in and join our deliberations. But yes, that's part of that is one ingredient in the toxic witch's brew that is making good science policy really hard. It's up there with the eye of Newt. Newt Gingrich in this case, but.
Michelle?
So it's clear that shared governance over an existential It's clear that shared governance over an existential threat is going to be very hard with the weakened WHO and the weakened UN right now in these times. So my question comes to you, David, about it's clear that this is going to fall into the hands of concerned scientists. And so what makes that body, and I'm thinking about what happened and why was it successful, the moratorium of ferret H5N1? It was clear that it was concerned scientists that really impacted that moratorium. Do you think that that can happen here?
Yeah. I think that useful things can result from the coordinated actions of key constituents like the scientific community, but I think in this case it has to be international. There are all kinds of reasons why we think now the U.S. cannot be seen as the lead on this issue. But in fact, our 38 co-authors hail from 10 or 11 countries, and many more now have signed on. And there are some organizations that operate internationally on behalf of scientific societies and so forth, as you well know. So our hope is that we can work through those international organizations and serve as a starting point, a foundation for a broader international conversation that is non-governmental. Track 2, if you wish.
Without the scientists, nothing is going to happen. With the scientists, it might happen. They're the seed, they're the yeast, they're the starter, but they need either some sort of public organizations or public policy, public opinion, et cetera, behind them as well. But yes, they're necessary, but they're not sufficient, I think.
What stopped the H5N1?
Michelle's question is, what stopped the H5N1 work? Well, it was a temporary pause that was, I think, forced on the US government by an outcry that came not just from scientists, in fact, much more so from the rest of civil society, from policymakers, from concerned citizens of all ilks and flavors, who were very concerned and wanted to see something done to buy time to talk about this more. Not a perfect example, but one that shows that moratoria can be had.
And I just want to drop in a little, I think, interesting footnote to the 1975 Asilomar Conference. They invited journalists. They were transparent and open, and they invited a lot of journalists. The best story to come out of it, both as a story and in terms of its public impact, was published in Rolling Stone. And so, don't just invite the New York Times.
Question here.
Yeah, this is a really difficult question to answer, but I'll ask it anyway. Time frame, you keep saying, we have some time, we have time. On a conservative basis, what would you say the time frame is before you might see this happen?
Yeah, there's a range of opinion about that. Almost everyone, excuse me, almost everybody would, I think, agree that we have at least a year or 2 or 3. Most people think that we probably have 10. Some people think more. If you ask George Church, the infamous molecular biologist from Harvard, he would say we've got 1 year, but I don't think anybody really agrees with that. We have years, plural.
George is going to have a living woolly mammoth next year, so
Yeah.
that's not going to happen either.
George, also a signatory on the paper, eventually tried to argue that we should embrace bubble worlds that we should all move into for when this does get released from a lab, and promote further efforts to colonize Mars because he thinks this planet may be gone for.
He's an interesting guy. Oh, but just on that, part of how long is how much money is going to be spent on it and how many scientists are going to be willing to work on it.
Yeah.
So if you've got $1 billion to spend on it, it's a lot shorter. If you've got bits and pieces of money, it's a lot longer.
But right now,
Probably.
it's definitely years simply because they're technical problems that have not been solved and will take time no matter what. Yeah, to reassure you.
A little bit related to that last one. When you're talking about risks and benefits and incentives, neither of you addressed the question of a sort of rogue actor looking for the ultimate weapon, kind of undeterred by the threat of mutual annihilation. So, both of you saw the remedy depending largely on the kind of international social compact and some kind of collective acknowledgement of the risk and need to contain that. But can you say a little bit more on this question of the timeline and the resource needs? What are the constraints in terms of resources and technical capacity that would actually give you some reassurance that the big thing to worry about isn't a kind of rogue actor, rogue government seeking, the ultimate bioweapon?
A couple of quick comments. I think we don't have a lot of time.
Yeah.
First, the technical hurdles include not just the need to chemically synthesize a large number of very complex mirror protein components, as well as a mirror genome, as well as creating a mirror version of a vesicle, a lipid membrane, but also understanding how to put those things together in a way that works. And that still is something that we think will take on the order of thousands of scientists working together to problem solve, even for the natural chirality form of synthetic life. So that's one thing that gives us a little reassurance. will any of these measures that we've talked about today thwart a determined bio-Unabomber? Probably not. But one thing that these measures might do is sensitize a large enough number of people around the world to the risk that come from someone doing this, that there'll be a person near to the bio-Unabomber who gets whiff of what that person is doing and tells somebody. It's, see something, call, kind of hope. I think that's the only thing we can hope for. This is not a rational weapon for anybody, but this is not a rational world.
This does make me think that if we see Kim Jong-un building a dome around Pyongyang, we should get nervous.
Thank you all for joining today, and we appreciate it. Thank you.